Now that you've practiced with negative exponents a little bit, we're going to utilize them in more complex expressions. We just have to remember that we need to follow order of operations. So in example 1, 2 times 3 to the negative 2, we need to evaluate that expression by doing the exponent part of it first. 3 to the negative 2 is 1 over 3 squared, or 1/9. And then 2 times 1/9 is the same as 2 over 1 times 1 over 9, which is 2/9. In B, we have parentheses, so what's inside of the parentheses needs to be done first. And so 2 times 3 is 6, and then that's raised to the negative 2, and that's 1 over 6 squared, which is 1 over 36. In C, we have a fractional base, so we're going to do the exponent part first. So that will be 3 over 1 raised to the positive 1. And 3 over 1 raised to the positive 1 is just 3 over 1. Now we can just multiply the fractions, and we have 6/7. In D, we need to do the parentheses first. 2 over 7 times 1 over 3 is 2 over 21. And that's raised to the negative 1 power. That would be 21/2 raised to the positive 1 power, which is just 21/2. Now we'll take a look at variable expressions. In E, we have 2 times y to the negative 3rd. So think of this the same way. We need to do the order of operations. That's 2 times 1 over y to the 3rd, which is 2 over 1 times 1 over y to the 3rd, or 2 over y to the 3rd. In F, the parentheses need to be done first, but we can't multiply 2 times y. So we can just think of this one as 1 over the quantity 2y raised to the 3rd power. When you have something that's a little bit more complicated inside of the parentheses, it helps to write out the repeated multiplication. That's 2y times 2y times 2y. So this is a 1 over 8y cubed. In C, we have m over 3 times 4 over m squared raised to the negative 1. So we need to do the exponent part first. That would be m squared over 4 raised to the positive 1 power. Well, raising to the positive 1 power is just m squared over 4. So now we can just multiply, and that'll give us m cubed over 12. In the next example, we have c over 3 times c squared over 2 raised to the negative 3. So let's raise that fraction to the negative 3rd power, which means raising its reciprocal, 2 over c squared, to the positive 3 power. So that'll be c over 3. Oops. To erase that. All right, c over 3 times 2 times 2 times 2 is 8. C squared times c squared times c squared is c to the 6th. That would be 8c over 3c to the 6th. And then we can reduce by canceling one of the factors of c. That's going to give us 8 over 3c to the 5th. All right, it is now your turn to try, so pause the video and try A on your own. For A, you should have gotten 5/8. Now try B. For B, you should have gotten 36 over 25. Now let's try C. The answer to C is A over B squared. Now try D. And the answer to D is x to the 7th over 63. Now let's try some examples where we have some additional operations. So in example 2, we have 4 to the 0 plus 2 times 3 raised to the negative 2. So we're going to want to do the exponents first. So we have 1 plus 2 to the 2 times 1/9. And 1 plus, and now the multiplication, 2 times 1/9 is 2/9. And now we need a common denominator, so 9 over 9 plus 2 over 9 is 11/9. All right, 3 minus 5 times 6 to the negative 1 is 3 minus 5 times, and taking care of the exponent first, we have 1/6. So that's 3 minus 5/6 once we do the multiplication. Now time to do the subtraction. We can write 3 as 18/6. and that'll give us 18/6 minus 5/6 is 13/6. Improper fractions are great. We want to leave things in improper fraction form in algebra. All right, in C, we need to do exponents first. 2 raised to the negative third power is 1 over 2 cubed, so that's 1/8. And 3 raised to the negative 1 is 1/3. So now we have 1/8 plus, and doing the multiplication, we get 5/3. So we're going to want a common denominator when we add. So that'll give us 24ths. So 3 24ths plus 40 24ths is 43 24ths. And I don't believe that reduces. And in D, we have x to the negative 1 minus 3 raised to the negative 2. So x to the negative 1 is 1 over x to the positive 1, just 1 over x. 3 raised to the negative 2 is 1 over 3 squared, or 1/9. Now we're going to want to subtract, and we need a common denominator. So that common denominator is going to be 9x. That means the numerator of the first fraction needed to have been multiplied by 9, and the numerator of the second fraction by x. Now we subtract those numerators and keep that denominator, and there's our final answer. In E, exponents first. So 1 plus 2 times 1 over n cubed. And then the multiplication. And now if we're going to add, we want a common denominator. So 1 can be written as n cubed over n cubed. Now we have n cubed plus 2 over n cubed. In F, exponents first. Now we want a common denominator. So our common denominator is going to be a squared b squared. So b squared over a squared b squared minus a squared over a squared b squared is b squared minus a squared over a squared times b squared. And that's it for that section.